This video is on descriptive statistics. We're going to be looking at the measures of spread. So one number that summarizes how spread out and consistent the data is what we're going to be finding. Now, data that is more spread out from each other is not as consistent as data that is less spread out. So the data that's more clustered together, we can see more information and the consistency of it. So when the data is spread out further away from each other, we have less consistency. So there are three ways we can look at how to determine if our data is spread out and consistent. We have the range, the IQR, which is called the interquartile range, and the standard deviation. So to start with the range is when we take the highest number and we subtract the lowest number. So we have the highest minus the lowest data point. So highest minus the lowest. When we're looking at data, this could be seen as the max value minus the minimum value. You might could see it as, if we're looking at the 5-number summary, this would be the Q4 piece of data minus the Q0 value. This data, or the range, talks about the spread of all 100% of the data. So it actually tells us how far away from the lowest to the highest is, which is all 100% of the data. So the outliers could affect this range because outliers would be considered part of the highest or the lowest. So we might have a lot of data in the middle, but then some data way out to the outside, which will affect our highest minus our lowest. So the range is non-resistant to outliers. Because again, I might have a whole bunch of data in the middle, but then one outlier at the end might say that all of my data is between this much room, versus most of my data is in here. So the range can definitely be affected by the outliers that are too much smaller or much bigger than the rest of the data. So the range is for the 100% of the data, so all of it. The interquartile range, or the IQR, is actually only the inside data. So to find the interquartile range, we take our Q3, which is the upper quartile, and we subtract the Q1, which is the lower quartile. So what this is it is the spread of the middle 50% of the data. Instead of all 100% of the data, is really focusing on just the middle section of it. So because I'm only focusing on the middle section of it, we do not have as much affection. The outliers do not affect the IQR as much as it does the range. So we could say that it's not as much affected by outliers. So we could say that it is more resistant to outliers. Because instead of having all of the data on the outside, we're going to be focusing more on the middle section. So then my information is more consistent with each other because they're not as spread out from each other. So most of my data would be in the middle, is what I'm talking about. So then I'm not going to have these outliers affecting my data as much. So I can say it's more consistent. Then we have the standard deviation. Now, calculating the standard deviation, there are two different ways. You can do it by hand, or you can use a calculator. There's also two different types of standard deviation based upon if we have the sample or if we have the entire population. A lot of times when you're doing standard deviation, you do not have the entire population, so we have to use very specific type of standard deviation. So in our calculator, since we're going to be using generally the sample values, we're going to use SX. or this is technically going to be, it's not really an S, it is a Greek letter, but we're using this symbol in our calculator, which if you go to stat in your calculator, we're going to then calculate a value, and we're going to just press the number 1 because it's going to be one variable statistics. And I will show this in a calculator after we do this by hand. So to do standard deviation by hand, we do the square root of the mean of the square of how far each data point is from the mean. Okay, so what does that really mean? So again, standard deviation is calculated differently depending on if the data points are a sample of the population or the whole population. So in this case, we're going to use a sample population. We're going to find the standard deviation of 65, 73, 76, 76, and 70. We need to first find the mean. So to find the mean, we're going to add up all of these numbers. So we're going to have 65 plus 73 plus 76 plus 76 plus 70. And then we're going to divide this value by 1, 2, 3, 4, 5. We're going to divide it by 5. So 360 divided by 5 is 72. So the mean is 72. So to do standard deviation by hand, we write out our data points, which were 65, 73, 76, 76, and 70. The mean was 72 for each of them. So we're just going to put the mean 72, 72, 72, 72, 72. So we're going to take the square root of the mean of the square of how far each data point is from the mean. So here's the data point, here's the mean. The deviation is how far away the mean was from the data point, almost like a residual. So what we're going to do is we're going to subtract these values. So we have 65 minus 72 is negative 7. 73 minus 72 is positive 1. 76 minus 72 is equal to a positive 4. 76 minus 72 is equal to a positive 4. And 70 minus 72 is equal to a negative 2. So we're basically finding the residual value away from the data point based off of the mean. But we have to take the square of how far they are. So we're going to take the square deviations. So when we take the when we square these, our squared deviations will be negative 7 squared is a positive 49. The square of 1 is equal to 1. We're going to take 4 squared and we get 16. 4 squared will get 16. And we'll take negative 2 squared and get a positive 4. So we've now done the square of the deviations. Now we're going to take the mean of these deviations and then we'll take the square root. So we're going backwards. We found the mean. We found the deviation from the mean. We squared those. Now we're going to find the mean of these squared deviations. So to find the mean of that, we'll take all of our values that we just got. So 49 plus 1 plus 16 plus 16 plus 4. And then we'll divide that number, 86. So we'll have the 86 divide by. Now here's where it gets a little different. It is not going to be divided by 5 because we are using the sample population instead of the whole population. This is just a sample value of data. We actually divide by 4 because I'm going to make a note here. We divide by 4 because this is a sample and is always divided by 1 less than how many there actually are. So that's why we have to divide by 4. So instead of finding the true mean, because we're doing a sample values, we're doing sample data points instead of the whole population, we cannot divide by 5 because we don't know the whole population. So we use 4. Then we're going to take the square root of this section. So we'll take the square root. So this is really the square root of, so if we take 86 and we're going to divide that by 4, we're going to have the square root of 21 and a half. 21 and a half. This will give us our standard deviation. So our standard deviation, Sx, is equal, we're going to go to the calculator, square root of 21 and a half, which gives us 4 64/100ths. 4 64/100ths. We also need to know, is standard deviation affected by outliers? Yes, because the outliers could be much further away from the mean, or it can really affect the mean itself, then our deviations will be changed because of the means. So yes, standard deviation is non-resistant to outliers. Non-resistant, remember, means that it is affected by the outliers because it cannot basically affected by outliers and non-resistant. Non-resistant, being resistant means it won't change it. Resistant means that it can fight against it. The non-resistant means that it cannot fight against the outliers. So our standard deviation is affected by the outliers, so it cannot fight against those outliers, so it's non-resistant. So if we do this data in the calculator, we would use, so we're going to go to stat, we're going to plug in our list, we're going to go to edit, we're going to type in 65 for our data points, 73, 76, 76, and 70. Then we're going to go to stat, we're going to go over to calculate, and we want the one variable statistics. So we're just going to press enter on number 1. Then we'll press enter. And our Sx right here is 4 64/100ths. Now, the other standard deviation is the sigma x, the lowercase sigma. This is the one that we would use if we had the entire population. So if this wasn't a sample. This would be the sample standard deviation is the big S. And that's how we would find standard deviation using the calculator.